Hey, today we're going to look at a couple of different properties of exponents. So first we want to look at these and write them in expanded form and then simplifying. So we're going to take x to the fifth times x cubed. So x to the fifth power, that means we have x multiplied by itself 5 times. So 1, 2, 3, 4, 5. And then we have x cubed, so we're going to multiply by itself 3 times. So 1, 2, 3. So then how many times did x get multiplied by itself in all? Well, there was 5 times, and there were 3 times. So altogether that makes 8. On this next one, 8 squared means we're going to take 8 times 8. Then we need to multiply that by 8 to the fourth power, so that means 8 times 8 times 8 times 8. 8 multiplied by itself 4 times. So that means 8 is going to be multiplied by itself 6 times in all, because we have twice, and then 4. So what did I have to do with those exponents of 5 and 3 to get to 8, and 2 and 4 to get to 6? I have to add them, right? So the multiplication property of exponents says that if I have the same base, to multiply them together, I'm going to keep that base and then add my exponents. So let's practice this. Over here we have y to the sixth times y. Now, y without an exponent there really means he's y to the first. So if we have y 6 times another y, means I'm going to have y 7 times. And I know that's going to be to the 7th because I'm going to add my exponents 6 and 1. Go ahead and try that next one. Yeah, that's going to be 7 to the 5th power, because we need to add our exponents 3 and 2. This next one is a little bit different. So we have p to the 0 power. Remember, anything to the 0 power is 1. Then we have p to the first power, and then p to the 5th. So we know we're supposed to add our exponents. So we'll end up with 1 times p to the 6th, or 1 plus 5. Now, side convo. Let's say you said to add exponents. So I had p to the 0 plus 1 plus 5. We still end up with p to the 6th, so the rule still works. That's one reason why I love math. You can solve things in lots of different ways, but as long as you do it correctly, you're going to end up with the same answer. Cool. Now these are a little bit more beefy, so we're going to have to be a little bit more careful. So we want to write the expanded form as well as the simplified form of the following. So if I want to write out 4 times x to the 6th, I'm going to take 4 times, and then I have x to the 6th, so x 6 times 1, 2, 3, 4, 5, 6. And then we're going to multiply that by 5 times x to the 4th. So we have 5 times, and then x to the 4th, so x multiplied by itself 4 times. 1, 2, 3, 4. So my regular old numbers are going to multiply together. 4 and 5. 4 times 5 is 20. Then I have x to the 6th and x to the 4th. All of that together gives me x to the 10th power. On this next one, a squared is a times a. B to the fourth is b times b times b times b. Then we have b to the fifth, or times b to the, I'm sorry, a to the fifth. So a times itself 5 times. So a times a times a times a times a. So we're going to bring all of those a's together. So we have 2 a's in the front, 5 a's in the back. Altogether that makes 7 a's. And then we only had 4 b's multiplying by itself, so we still have b to the fourth. Okay, so with that in mind, let's rock this. All right, over here, first we're going to take care of our regular people numbers. We're going to multiply 6 times 4. 6 times 4 is 24. Then we have z multiplied by itself 4 times, and then z multiplied by itself 3 times. So that means I'm going to have to add those exponents, 4 plus 3. So we're going to end up with z to the 7th power. So 24z to the 7th is our final answer there. All right, on this next one, we're going to multiply our normal numbers together. So 4 times 3. And we know 4 times 3 is 12. Now let's take a look at what's happening with our c's. So we have a c to the 3rd power, and then we have another plain old c. And remember, he's technically to the 1st power if there's nothing there. So that means altogether we have c to the 4th power. N to the 5th right here, there's nothing else with n as a base. So he's just going to come along for the ride. So we'll end up with 12c to the 4th, n to the 5th for our final answer. Okay, on this next one, we don't have anything for our 5 to multiply with, so we're just going to bring him along. Now, these z's feel a little bit awkward, right? But we know the rule is that my exponents, when I'm multiplying their bases, I add their exponents. So I'm going to take 4 plus -3. And then there's nothing to combine with y, so y squared will just stay y squared. Now we'll go ahead and simplify. We have that 5. Z to the 4 plus -3 means it's z to the 1st, or just plain old z. You can have a 1 there if you'd like. And then we have our y squared. Good deal. This last one is pretty beefy, but we got this. So, what normal number can I multiply by 4? 2. So we'll take 4 times 2, and we'll get 8. Now let's look at our a's. So I have an a cubed, and then we have an a to the 4th. So I have 3 a's and 4 a's. Give me a total of 7 a's, because we need to add our exponents. So we have a to the 7th. Now we'll look at our b's. So we have b to the 0 and b cubed. So either you can think of this as b to the 0 plus 3 power, which would just be b to the 3rd. Or you could think of it as b to the 0 power. Anything to the 0 power is 1 times b cubed. Just gives you b cubed for that term. Good deal. Then we have this C right here. Do we have anything else with the C in it? No, so he's just going to come along for the ride. Good deal. Now we want to write this in expanded form and then simplify. So we have y to the 8th in our numerator, so that means we have 8 y's on top. 1, 2, 3, 4, 5, 6, 7, 8. Divided by y to the 6th. So 1, 2, 3, 4, 5, 6 y's. Now remember, when we have the same factor on the top and the bottom being multiplied, we can divide those out and cancel them. So y divided by y cancels, y divided by y cancels, y divided by y cancels, until all we're left with are 2 y's up on top. Now, technically, that's over 1, but we don't normally write that. Let's look at this next one. We have 3 to the 4th power, so that means I have 3 times 3 times 3 times 3. Divided by 3 to the 7th, so 3 times 3 times 3 times 3 times 3 times 3 times 3. Once again, those guys, since they're being multiplied, 3 divided by 3 is going to divide away to 1 and cancel out. So these cancel out, these 3's cancel out, these 3's cancel out, and these 3's cancel out, until we're left with those 3's. Notice they're on the bottom this time. There's 3 of them. If there's nothing on top, we always have to put a 1. Good deal. So what you might have noticed with 8 and 6 to get to 2, and from 4 and 7 to get to 3, what we'll do is we will subtract the exponents. So x to the a divided by x to the b is going to be x to the a minus b. Now, that's always going to be true. Let me have a quick little conversation with you over here about this problem. Now, let's go ahead and subtract those exponents like our rule says. So our base is 3, and then it says to take 4 minus 7. 4 minus 7 is negative 3. We learned last time about negative exponents that if he sat up there on top, he has to move down to the bottom and be 1 over 3 cubed. So what I tend to do is I subtract my exponents, but then I think, where is my bigger exponent? If my bigger exponent is on the bottom, my stuff is going to stay on the bottom of the fraction. If my bigger exponent is on top, it's going to stay up on top. Honestly, what I do with division is I think about exactly what this is. What's going to cancel out? How many are left? And where are they? Are they up on top or are they on the bottom? So we have 4 to the 6th divided by 4 squared. So we can think about this as 4 times 4 times 4 times 4 times 4 times 4 divided by 4 times 4. Those 4's cancel out. So I am left with 4 to the 1, 2, 3, 4th power. Or you could have said, all right, my base is 4, we got him, and then we'll take 6 minus 2. Go ahead and try the next one. Yeah, so we'll end up with w to the 4th. Either you thought of 7 w's up on top and 3 w's up down on the bottom. When those 3 w's cancel out, we're left with 4 w's up on top. or you took 7 minus 3 for that exponent. In that next one, we're taking x squared, so x times x divided by x. Those x's will divide away, so we're just left with plain old x. Or we can remember that this guy, if there's no exponent on him, that's a 1. So remember, technically, there's a 1 right there. If we take 2 minus 1, we get 1. All right, now let's look at this next guy. So I'm not the biggest fan of just taking 2 minus 6 and then moving on with my life because I can never leave something with negative exponents. That's a bad thing to do. So here's how I like to think about it. I have 4 squared on top. So that means I have 4 times 4 in my numerator. On the bottom, I have 4 to the 6th. So I have 4 times 4 times 4 times 4 times 4 times 4. Those 4's will cancel out. So I am left with 4 4's on the bottom. If I don't have anything left on top, there's a 1. So what I like to do in this case, I'll take 6 minus 2 and get 4. And then I would say, okay, once I divide things out, where will my 4's end up? In my numerator or on my denominator? I'll end up in my denominator. This next one, there's a couple of different ways to think about it. So let's go strictly by the rule. Let's say we're dividing, so let's subtract the exponents. X minus 4 minus 9. Subtract those exponents. So when we simplify that, we end up with x to the negative 13th power. Well, we can't leave something with a negative exponent. So if he's sad up on top, we're going to move him down to the bottom in our denominator. And now our exponent is positive and happy. And since we don't have anything in our numerator, we need a 1 there. Here's another way for us to think about it. X to the 4th is sad where he is. So let's bring him down to the bottom. So now x to the 4th is positive and he's happy, and we still have that x to the 9th. We don't have anything on top anymore, so we have to put a 1 there. Now we're multiplying our bases on the bottom, so we'll add our exponents. So we'll end up with x to the 13th in the denominator. So either way, we'll still end up with the same answer, just different ways to think about it. Great. On that last one, we have a to the negative 2nd power. So either you can go through and subtract like we talked about a second ago. So we can say here we have a to the 1st minus, and then I'm subtracting negative 2, right? So minus negative is plus or positive. So that's the same thing as a cubed. Or we can say a is a negative exponent down there, and he's sad. So we're going to bring him up to our numerator to make him happy. So now we have a squared up on top times an a to the 1st. Remember, that's technically over 1, but we don't usually write it. So then we add our exponents and end up with a cubed. So whichever way you think about it, you're going to end up with the same value. Okay, so now this monster, we are going to write in expanded form and then simplify it. So on top in our numerator, we have x to the 4th. So that means x times itself 4 times. And then we have y squared, so we have 2 y's. Over y to the x to the 1st, so just 1x. And then y to the 5th, so we'll have 5 y's. Good deal. So now let's cancel out what we can. We can cancel out one set of x's, and we can cancel out 2 sets of y's. So on top, I'm left with 3x's, or x to the third, over, and on the bottom, I'm left with 3y's, or y to the third power, or y cubed. Cool. So let's take a look at these. I'm going to have to move my face real quick. There we go. All right. So we have 5 to the 6th over 5 to the 6th. Let's talk about that right there. Now, that's the exact same number on top of itself, right? 5 to the 6th over 5 to the 6th. So if I have 6 5s on top and 6 5s on the bottom, those would all divide away and cancel out, right? So 5 to the 6th over 5 to the 6th cancels out. Now all we're left with is 3 to the 4th over 3 squared, or 3 to the 2nd. So I have 4 3's up on top, 2 3's on the bottom. So then 2 of those 3's will cancel out. We're left with 2 of those up on top. So 4 3's on top, 2 3's on the bottom. These 3's will divide away. So we're left with 3 squared up on top, since we have 2 3's. Or, since we're dividing, we subtract our exponents, 4 minus 2. Okay. In this next one, my advice is to take your time, work each variable individually, and then you'll be good. So first, let's talk about plain old numbers. We have 4 on top and 12 on the bottom. Now, we've talked about simplifying fractions before, and that's exactly what we're going to do. 4 divided by 12, 4 goes into both of those numbers, so 4 divided by 4 is 1, 12 divided by 4 is 3. So far we have 1/3. Now we have x squared over x. So that means I have 2 x's up on top multiplied by itself, divided by an x. One of those cancels out, so we're just left with one plain old x. Now let's look at our y's. So we have a y in our numerator and a y to the 4th in our denominator. So that means we have 4 y's down on the bottom. One of the y's in numerator and denominator will cancel out. So we just have 3 y's left in the denominator. So we have 1 over y cubed. Now let's take a look at the z's. So I have a z to the negative 4th on top and a z cubed on the bottom. So we have negative 4 up on top. He's a sad exponent, so he needs to move to the bottom to be happy. So now we have a 1 on top, z cubed times z to the 4th. So I have 3 z's times 4 z's gives me 7 z's. So now let's put all of this together. I'm going to go ahead and make my fraction bar. So we have this 1/3. I'm actually just going to ignore the, 1/3. We'll put times and times. For my x's, we had an x on top and nothing on the bottom. Times. And then for my y's, I had a 1 on top and a y cubed on the bottom. Times my z, I had a 1 on top and a z to the 7th on the bottom. So 1 times x times 1 times 1 is x. 3 times y cubed times z to the 7th power is 3 y cubed z to the 7th power. I know, a little beefy. All right, I'll see you guys a little bit later.